I'm T. Lee, a certified flight instructor. To the pilots taking this lesson to advance their skills and careers, this briefing details the specific legal and documentary requirements for professional aviation operations. Your legal identity as an aviator begins with FAA Form 8710-1. Signing this application acknowledges the Pilot's Bill of Rights and the Privacy Act, allowing the FAA to use your data for certification investigations. This information is integrated into the Safety Performance Analysis System and the Air Carrier Analysis Support System, and it documents your status regarding DOT-required drug and alcohol testing. Once certified, your operational history must be documented under Part 61. For a logbook entry to be legally binding, you must record the date, total flight time, departure and arrival locations, aircraft type, and flight conditions. Your certificate tier defines your operational privileges. A private pilot is limited to paying a pro rata share of operating expenses and flying for incidental business. A commercial pilot may carry persons or property for compensation, though they face specific cross-country and instrument limitations depending on their ratings. To exercise these privileges, you must maintain a valid medical certificate and meet recent flight experience requirements. Under Rule 61.57, night currency specifically requires logging 3 takeoffs and landings to a full stop between 1 hour after sunset and 1 hour before sunrise. Your authority to act as pilot in command depends on the continuous update of your certification and currency records. The aircraft itself is governed by 14 CFR Part 21. An airworthiness approval certifies that the machine conforms to its type design and is safe for operation. We distinguish between an article, any material or component, and a commercial part included on an FAA-approved list. A design approval defines the aircraft blueprint, while a production approval allows the manufacturer to build it. FAR 21.2 prohibits the falsification of these records. If a product exhibits a major defect in service, FAR 21.3 requires a report within 24 hours. This mandate covers catastrophic failures, like onboard fires, toxic gas accumulation in the cabin, and primary structural defects. For extended operations, or ETOPS, Part 21.4 requires manufacturers to track world fleet reliability. 2-engine airplanes must maintain in-flight shutdown rates at or below 0.05, 0.02, or 0.01 per 1,000 engine hours, depending on their specific approval level. Every operation also requires a Current Approved Airplane Flight Manual, or POH. When the FAA identifies a persistent unsafe condition, they issue an airworthiness directive under Part 39. These are legally enforceable rules that mandate us. This matrix shows the required timelines for aircraft registration certificate renewal. You must apply for re-registration within the specific window assigned to your issuance month to avoid expiration. If an aircraft is imported, the previous foreign registration must be officially invalidated by that country's registry. An aircraft's legal status is maintained through this cycle of continuous reporting and regulatory compliance. Atmospheric physics define the performance envelope of the aircraft. For dispatch planning, you must use area forecasts, issued 3 times daily, and winds and temperatures aloft forecasts, which provide data for 6, 12, and 24-hour periods. Pilots are required to synthesize surface analysis, weather depiction, radar summary, and significant weather prognostic charts. You must also distinguish between hazard thresholds, air myths for weather that may affect safety, and SIGMETs for severe or extreme conditions. This requires a mastery of cloud theory. Low clouds, from the surface to 6,500 feet, often contain supercooled water droplets that freeze upon contact with the airframe. Middle clouds, up to 20,000 feet, include altostratus layers that pose icing and turbulence threats. High clouds, forming above 20,000 feet, consist primarily of ice crystals. Clouds with extensive vertical development grow from low-level bases up to high altitudes. Because of this span, they contain various water formations: liquid, supercooled, and ice, depending on the local temperature and altitude. In their mature stage, these massive vertical structures form cumulonimbus anvil tops. This visual signature is the primary indicator of extreme internal turbulence and severe thunderstorm potential. Interpreting these charts and visual signatures is how a pilot prevents a legally airworthy aircraft from entering hazardous atmospheric conditions. We move now to Task C, Systems operation. Advanced airmanship requires diagnosing the physical root cause of an instrument anomaly in flight. The pedostatic system measures ram air pressure against outside static pressure. Whether you use a G1000 or legacy round dial instruments, the sensors rely on these two distinct pressure sources to calculate your airspeed, altitude, and vertical speed. If the pedo tube is blocked, but the drain hole and static port remain open, the airspeed indicator will drop to 0. However, if the entire pedo head is blocked, the trapped pressure causes the airspeed indicator to act as an altimeter, erroneously showing a higher airspeed as you climb. A blocked static port freezes the altimeter and drops the VSI to 0. Opening the alternate static port inside the cockpit exposes the system to cabin air, which is lower in pressure due to the Venturi effect. This causes your airspeed and altimeter to indicate slightly higher than normal. You must also monitor the electrical system. An ammeter shows whether the battery is being charged or depleted. A load meter, however, only shows the positive load placed on the alternator, common in 14-volt systems like the Piper Arrow. If the vacuum system fails, you must rely on the magnetic compass, which is subject to specific errors: variation, deviation, magnetic dip, and turning errors like UNIS, undershoot north, overshoot south. Accurate diagnosis requires interpreting gauge anomalies as specific mechanical or pressure-related failures. Task D covers performance limitations. Performance is governed by the center of gravity. An aft CG reduces the amount of elevator deflection available at low speeds, leading to light control forces and the risk of an unrecoverable flat spin. This chart is used to derive density altitude. By tracking outside air temperature against your pressure altitude, you find the exact atmospheric density used to predict takeoff and climb performance. This chart allows you to calculate wind limits. By tracing a 30-degree wind angle from the nose, you determine the exact headwind and crosswind components for your chosen runway. This graphical method calculates takeoff distance. You track the data through matrices for temperature, weight, and wind velocity to find your distance over a 50-foot obstacle. Using the tabular method for a 2,400-pound aircraft at a 3,000-foot pressure altitude and 30 degrees Celsius, the calculation results in a 1,060-foot ground roll and 1,984 feet to clear a 50-foot obstacle. This chart provides your climb performance forecast. From the departure temperature, you intersect lines to find the fuel, time, and distance required to reach your cruise altitude. In this tabular example, departing at sea level at 22 degrees Celsius and climbing to 8,000 feet at 3,400 pounds requires 11 minutes, 23.1 pounds of fuel, and covers 22 nautical miles. This chart determines cruise power settings. At 6,000 feet under ISA plus 20-degree conditions, the table identifies the manifold pressure and fuel flow needed for maximum continuous performance. Finally, this table dictates range and endurance. At 5,000 feet and 2,400 RPM, with 38 gallons of fuel, the aircraft achieves 5.5 hours of endurance and 635 miles of range. Precise charting converts atmospheric physics into survivable dispatch parameters. Task E details airworthiness requirements. Airworthiness means the aircraft conforms to its type design and is safe for flight. Every pilot must distinguish between the FAA-approved airplane flight manual and the manufacturer-developed Pilot's Operating Handbook, which contains 9 standardized sections for aircraft operation. The pilot in command is responsible for verifying airworthiness through maintenance records. This includes checking for the completion of required annual and 100-hour inspections. Every legal logbook entry must include a description of the work performed, the date of completion, and the signature and certificate number of the mechanic approving the aircraft for return to service. This entry is a real-world example of those requirements. You can verify the date, the signature of Joshua Merrill, and his A&P certificate number with the inspection authorization rating. Ultimately, the aircraft's capability for flight is legally granted by these endorsements, linking physical maintenance to regulatory approval. If equipment is inoperative, you must follow a deferral process. If the aircraft has an approved minimum equipment list, or MEL, you must follow its specific instructions for dispatch. Without an MEL, you must check if the item is required by the VFR Day Type Certificate, AFR regulations, the POH equipment list, or airworthiness directives. If not required, it must be deactivated or removed and legally placarded as inoperative before flight. If the aircraft is not airworthy but capable of safe flight, AFR 21.197 allows for a special flight permit. These are issued by a local FSDO or DAR for purposes such as flying to a maintenance base or production flight testing. Professional flight operations integrate stick and rudder skills with the rigorous management of regulatory and environmental data. I'm T.H. Lee. Fly safe.